Hello everyone, welcome to MLAS100, Learning Activity 1, History of Machine Learning and Autonomous Thinking. So when we talk about machine learning, I like to go back in time. I like to go back and get people who are interested in machine learning to think historically, how far back does machine learning go? Before we even jump into any of the theory and the machine learning algorithms and the modeling and the model evaluation and AI model embedding and all of those things are great, and we're going to cover all of those as we go through the curriculum and more. And as you hit the different classes throughout the curriculum, you'll definitely get a lot of expertise in all of those areas. But before we jump into that, let's talk about the history. Let's talk about the culture. Where does it come from? How far back do we go when we're talking about machine learning? So to start this off, let's talk about one thing first. How do we get here, and why do we even have artificial intelligence to begin with? Where does this come from? Where does the need for this come from? So one of the needs comes from this thing called data. And so there's this idea that there's data, it's all through the universe, it's indestructible. You have these underlying pieces of information that describe whether it's an atom, whether it's whether it's a light, whether it's a planet, whether it's a galaxy, a black hole, a computer, a person. It can all be described by data. There's this concept that actually data is almost a fifth dimension of the universe, and there's actually a lot of work that's going into understanding that at a quantum level. But there's still some work to be done. But there is evidence to suggest that data is almost a fifth dimension, as it were, of the universe. So, data, indestructible. And why is that important to artificial intelligence? Well, it leads to what's called information. So we take data, and you take these underlying units and all these little physical quantities of the universe, and then you collate them and coalesce them, and then you create what's called an information, a unit of information, right? You take a lot of bits of data, and then you take that and then create information that's useful. It's insights that are created from data, and we capture this information, we make sense of it, and usually we store it in databases, but it could be a JSON file, it could be a SQL Server database, it could be a columnar data file, it could be an XML data file. It could even be a book, right? It doesn't have to be. It could be notes on your notepad. In other words, it doesn't have to be this thing that's in digital form. But anyway, information is then taken, and there's another level. It's taken up a notch to what we call knowledge. And knowledge is an awareness gained by experience that's created from information, and information created from data. So there's this whole gradient where I've got data that leads to information, information that leads to knowledge. But I do want to take it one step further, in that knowledge is actually something that's derived from a shared awareness or a shared understanding of the information that we gather. And what I mean by that is, for example, let's say I create a cup. So, we create a cup to hold water, and we use different materials based on the information that we glean around the environment around us. We say, hey, plastic would be a good material to form for usage to create a cup. And from that, we can create this knowledge, that we say, okay, we all agree that the cup can hold water. We can also all agree that the cup, if let's say we give it a color purple, if none of us have issues with color blindness, we could probably 99% of us could say, hey, we look at this cup, we all agree that it's purple. And that's what we say. Taking it to a next level is it's that interconnectedness of knowledge that we all agree on, that drives to shared awareness around information that we gather. Now, As it relates to us in this world, we are a very small dot. This isn't even to scale, right? We're not even a grain of sand. We're so much smaller. So much smaller when it is put into comparison in terms of the total amount of information in the universe, right? It's just an unfathomably small number in terms of where we are in this whole data information knowledge chain. And I say that because this actually sets us up for why it's so hard to do what we do next, which is how do we take data and make it useful? We turn it to information, then we take that information, turn it to knowledge. So back in the old days, so if you back up even 200 years ago, right, before we had an ability to really share information quickly, we had to send letters. We had to write stuff down in books and then send books via horse carriages, and it was tough to get data around the globe, much less take that data, transform it into information, and then put it into knowledge. But nowadays, it's so much easier because we have a lot of digital assistants that help us, right? And I'm not talking about like phone digital assistants, but software at corporations that helps to shape all of the data that's around us and put it into data stores so that it's reusable by all of us on our computer, on our phones, on TV. We just have all this ability to today collect this information. But we're constantly on the hunt for that information. So it's this gap between data and knowledge. It takes a lot of effort to get this movement of these basic underlying units throughout the universe and turning it into usable knowledge. So we're hunting for data constantly, whether it's we're farming it, whether we're looking to create it, or whether it's just a lot of hard work that goes into taking this data and creating knowledge. So now this is where AI comes into play, and a lot of times when we're talking about AI, of course we have visions of Terminators, we have visions of Skynet, and we constantly are thinking that this is what the future of AI looks like. But for us, and really why we're trying to create and why we use AI and artificial intelligences today, is to shape data and conform it to knowledge, and then close that gap. That's really what we're trying to do. And this has a lot of implications. This is also, of course, people come to mind, well, what about robots that are used for human purposes to, do things more quickly? It's all in the effort to connect us, right, and get us connected, whether it's creating a Tesla car with, in a gigafactory with a lot of robots that are automating a lot of the functions that go into that, or whether it's something as it relates to the creation of software at an organization. They both serve a purpose to make our lives easier so that we can attain more knowledge as a species. That's really kind of our big thing, right? We have AI. We want our cars to be automated. Of course we do, right? One, for safety, but also from a time perspective. Because how cool would it be to be in your car and be able to work on creating knowledge while you have a car that is ushering you along, instead of you focused on driving, you're focused on your work, or you're focused on connecting with family, or you're focused on other things that are more expedient in terms of your life, that you want to help make more efficient. Now, with that, that gets us into some complications, though. So let's talk through what does that look like, because it's not all rose-colored in terms of the way that not everyone sees it the same way. And the first thing we want to talk through is that I want to describe to everyone is that there's a gradient. when we talk about artificial intelligence, there's the positive and there's the negative. So let's start off with the negative. So Elon Musk has come out and said that artificial intelligence is more dangerous than nuclear weapons. Bill Gates has said a little bit more apprehensive, but says humans should be worried about artificial intelligence. Katie Crawford, who also works at Microsoft, she's a researcher there, says that it's more rational approach that AI should reflect the values of its creator. Masayoshi-san, who is he's a billionaire and was the CEO of SoftBank, I think, at the time. I'm not sure if he still is, but very influential business person, and kind of more on the positive side, going to be more of our partner. And then you have, of course, Jeff Bezos, who says that we're on the we're in the golden age of artificial intelligence, and we really are, because there's a lot that AI can be used for to really help humanity, and continues to do so today in terms of being able to uncover insights in data that we collect in a way that we would never have been able to collect even 10, 15, 20 years ago. Now, this brings up quite a few questions, of course, and so let's work through the three of them. So, the biggies, right? Big one is, where did AI come from? What does it look like today? And where do we go from here? So let's start off with, where did it come from? And this gets into my favorite part, which is the historical perspectives of artificial intelligence. So when you look back in time, I like to discuss the beginnings of artificial intelligence from a cultural perspective, because when you look at the AI from that perspective, you can actually go back really far in time. So actually 40,000 years in time. So there is the Lion Man, or the lion head figurine, that was created back by prehistoric humans 40,000 years ago in Germany, or what would be modern day Germany. We also have Venus figurines that were created by prehistoric humans back during this time period as well. And these are artificial beings, right? And it was very clear, especially with the Lionhead Man, that this was almost a Frankenstein kind of being that was created. This isn't something that prehistoric humans saw back then. They didn't see a human running around with a lion head, or this kind of weird, hybrid human. This was something that they had put together because, really, quite interestingly enough, through their own creative thought, this is an artificial construct. This isn't something that they saw physically. So anyway, this is something that was artificial. So now you go forward in time. There's another one called the Shiger idol, and that was 12,000 years ago. And then there's a lot of figurines that were actually created from 40,000 years ago, or well, it'd be 42,000 years ago, to about almost 3,000 years ago. We come forward to Pandora, on what you are familiar with in terms of Pandora's jar. But Pandora in the Greek mythology, Pandora's box. That is the famous story. But she was the first woman that was created by Hephaestus. And so if people remember their Greek mythology, Hephaestus was the god of technology. He was technically the god of blacksmithing and weaponry, right? And so, but for them, that was the technology, right? So Hephaestus is technically the first god of technology that we had created as human beings, that we had envisioned. And Hephaestus created from the earth Pandora. So she, we had created this concept of Hephaestus. We also imbued Hephaestus to create Pandora through our literary works. So Pandora is quite literally an artificial being that was created by another artificial being, if you want to take it even a step further. So Pandora, very interesting concept. I highly recommend people to, if you have not, read Hesiod's Theogony. There's a lot of fun stuff in there. If you fast forward from there about a few hundred more years, Talus, or Talos, depending on how you want to pronounce it, but was in the Apollonius Argonautica. And if anyone remembers Jason and the Argonauts, Talus in Greek mythology was a giant automaton made of bronze, and actually was made to protect Europa on the island of Crete from pirates and invaders. And he actually, this big mechanized being, circled the island 3 times daily. So it was an interesting and a giant being that protected Europa from invaders. But yeah, that's an actual mechanical envisioned machine. So that you're talking about 2,300 years ago. Then you've got Gollum. Gollum is an artificial being in Jewish folklore created from the very earth itself. Nabis, the Iron Apiga, that is actually the Iron Maiden. That's where we get the name from. Was actually a torture device, but it was an automaton that was built to collect taxes from people who didn't pay. So I think the rumor is that it never got used because upon seeing this Iron Maiden, they actually paid their taxes. Just the very thought of being put into it, they would pay their taxes. So anyway, this is something that shows up in the history books as an automaton. Another one is on the Chinese side. 500 years ago, I should say. Now this is in the Common Era, so this would have been about 1,500 years ago. King Ling's dancing robot showed up in this is kind of getting out of the literary, but this is a concept of a automaton that was created for the King Ling's court. The devices of Banu Musa, which is actually coming from the Middle East or the Ottoman Empire. This is actually the brothers of Banu Musa, and Banu Musa, the books that were created and detailed all kinds of fascinating machines, so far ahead of its time. But many a lot of interesting mechanical devices that I highly recommend you do a Google search on and learn more about. Then you go into King Arthur, and so you're talking about almost 900 years ago. Copper men show up in King Arthur's Percival. So this is something that you see regularly. This is there, and when you look culturally back, from 3,000, 2,000, 1,000 years ago, we have so much of a vision for these artificial beings. We couldn't really realize it until we started to get into what I call the paper period. So 1,500 years ago, a polymath by the name of Girolamo Cardano, so Italian polymath. It's an interesting character in the history of AI and machine learning. Cardano was broke, and he was had a gambling problem. So he said to himself that he needed to create a book on games of chance, which actually laid the framework for game theory and statistics. He didn't formalize statistics, but he laid some principal concepts down that were used in a lot of what we find for the framework for statistics. If you fast forward into about another 150 years, Pascal and Pierre de Fermat, who was a French lawyer, actually created the mathematical theory of probability. Then moving forward to Edmund Halley, he created a statistical human mortality table. And then in 1761, Thomas Bayes proves Bayes' theorem, or what we'd call proves conditional probability. So completely, this was a big game changer because conditional probability is a big component of, if you haven't taken stats yet, you will come across it. And if you've taken it, then you're probably somewhat familiar with it. But in the lower right-hand corner is conditional probability, and you can spend a little bit more time understanding that. But this is something that really breaks the mold, because from 1700 moving forward, things speed up quite a bit. So in early 1800s, Charles Babbage created the first what I call a mechanical computer, like an industrial grade mechanical computer, because technically you could say the Antikythera mechanism was a computer too, and it is, just for astrological purposes, then, or astronomical, let me rephrase that, astronomical purposes. Um, and then you've also got the abacus, right? A calculator. It's a computational engine. But Babbage's differential engine is different because it had the capability to do what was called symbolic programming. Ada Lovelace, who she made some interesting insights into Babbage's machine, that allowed for them to build off of that and create what we'd consider modern programming. So kind of moving forward into, through the years here, you've got Turing's cryptographic bomb. Alan Turing didn't develop the cryptographic bomb. Actually, it was developed in Poland during World War II. When the Polish ran out of money, they gave it over to the UK to continue development on breaking the Germans' cryptographic machine, right? The Enigma machine. So they had Turing specifically was instrumental not just in that, but he actually had so many more contributions, considered quite to a large extent the father to a large extent of artificial intelligence, because he really set the groundwork for even asking the question, and we it shows up in our Turing test, but ask the question, can machines think? So it's very it's unfortunate he died so early, but he was definitely a titan and still is a titan in the field when it comes to artificial intelligence. 1949, Phillips creates the Mosaic fluidic logic machine, and then after that we get into the silicon period. From here we start to see tubes starting to go out of favor rather, because a lot of the machines that were electric machines built in the iron period used tubes. And then moving forward, we started in the 60s, we started to get into integrated circuits and transistor, and being able to shrink computational devices down ever so smaller, right? So you look at Stanford creating a robot that can navigate a room in the 70s. IBM's Deep Blue beats Garry Kasparov. Generative adversarial networks show up in 2014 they were developed. And then deepfakes of Tom Cruise show up in 2021. So that's kind of brings us all the way from 40,000 years ago or 42,000 years ago to the present. So what does that mean for us today? So when we talk about what's going on today, I think one of the things that people want to know is and especially for us in the machine learning world, we probably want to know, how is AI categorized? Well, there's different ways to do that. This is an early version of that. There are different ways you can categorize artificial intelligence, but there's some big buckets, which is reactive machines, machines that have limited memory, machines that are a theory of mind, which is Google Duplex. We'll see a quick video of that. And then there's this concept of self-aware machines. And this is the area where there's actually been a lot more thought, as of just even this year, around this concept of the singularity event. And people have stepped back and said, well, what is self-awareness as it relates to, let's take artificial intelligence off the table. Let's just talk about what does it mean to be self-aware. So if you think about yourself as growing up as a baby, and to your modern day self, you didn't have any awareness when you were born. You didn't have any awareness at the age of 6 months. Really, most won't have an awareness at the age of 1 year. Though it probably happens. I'd say it's rare, right? But then, maybe you start to see more people that have their first memories at the age of 2. First memories, most of us probably have our first memories at the age of 3. And then going beyond that, right, we still don't have, even if you think back on what was self-awareness to me at the age of 3, we probably really weren't even self-aware at the age of 3. We really don't have awareness as humans. It really doesn't take hold until about 4, 5, 6, kind of sometime in that time frame. And in some cases, depending on whether it's other issues can arise where even some humans never gain or have self-awareness, and that just depends on other set of circumstances that kind of extend beyond this course. But I'm sure you can obviously think through a lot of those types of situations. But for us in everyday kind of situations, self-awareness is very difficult to pin down even for humans. So where I'm going with that is if we now reintroduce artificial intelligence back into the conversation, there's a lot of discussion around, well, there's a gradient even within self-awareness as it relates to even maybe limited self-awareness to more full awareness like what you have today. Another way to think about this is like our dogs. If you've ever been around dogs, or if you've ever been around dolphins, if you've ever spent any time with non-human primates like chimpanzees or bonobos, you'll know that there is a self-awareness on some level with regard to certain animals versus other animals. Like when I look at chickens, they don't have quite the same self-awareness that a chimp does. So there's gradients of self-awareness in there. Now humans and dolphins probably exhibit, and probably octopi or octopus probably have the most in elephants, right? We just in testing, we know that there are probably some entities on Earth that are right now biological entities on Earth, probably 3 or 4 of them, including humans, that have a very strong ability to maintain or understand themselves. So this is a very interesting concept. So I don't, and a lot of scientists theorize, and this is an interesting part, that some machines today exhibit limited self-awareness. So that's something to be thinking of, especially for us in this field. Okay, so with that, let's jump into where is it used today? And a lot of people say, is it going to be used? Is AI ever going to be used? And the reality is, it's not a question of if. It used to be a question of if you backed up 20 years ago. Now, today, it's not a question of if, it's happening. So journalism, gaming, manufacturing, finance, healthcare, it doesn't matter, whether aerospace, space, we use it everywhere. So that's something to keep in mind. Now, you want to know how good it is. So this is Google's famous hair salon appointment. This video won't play very well here, but there's a YouTube link here, and I'm gonna switch it real quick over to the YouTube. I'm gonna and then I'll play it from the YouTube video. Okay, so let's get this going and see if this comes through.
So how can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have it 10 o'clock. 10 a.m. is fine. Okay, what's your first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
So that is very much one of the more advanced AIs that you're going to come around, and that was 2018, and they have gotten way better than that. That was 2018. We're talking about 4 years ago. And so AI has changed so much that Google, this is Google Duplex, so you can go check this out. There's ups and downs. It's got some domain specific things, and you can see AI kind of sometimes going off the rails, depending on the training data that they fed it. But where I'm going is AI has gotten really good to the point where a lot of these tools they have blown past the Turing machine test. So the Turing test. So if you look at what's on the left here, this is the machine on the left. The person on the right was a human, And so that right there, I don't think the person on the right knew that it was talking to a machine. This is a clear advancement. I would say probably 100% of the people that were on the phone probably wouldn't have known that that was a machine that they were talking to, which means that the Turing test had to be reevaluated because our machines have blown past. It used to be like, how many machines are going to be available, or I should say that we've developed. We don't know if they're going to ever be able to pass the Turing test. Well, that happened a long time ago. We blew past that, and so now they've revised that to for the Turing test to be more comprehensive, because machines now, especially our chatbots, and these more advanced machines that we've got like this, if they're on a phone and you can't tell that it's a machine, then for all intents and purposes, you think you're talking to a person, which brings up some interesting ideas to ponder. Okay, next up. All right, so robotics used in journalism, right? So we've got it here in this case. This was back in, this is a while ago. This would have been about 2017, if memory serves. Robotics in journalism, it's used quite a bit. So if you read through this was actually written by a robot. Pretty interesting, because a lot of people don't realize that a lot of the media that they take in, it's AI driven. Next up, artificial intelligence in gaming. Now this is still some areas where we're holding artificial intelligence at bay, which is Dota 2, very complex games. 5-on-5, humans typically are able to beat AIs. That's not always the case. Where the machines have totally mopped us, that will never win ever again. AI has beat us at Go, the board game Go. So Go is very, very complex. So I put it down here is that board configurations for Go are 10 to the 170. And so they say that and just to give you an idea of how complex that is there's 10 to the 80 atoms in the observable universe. So that means that in this case there's 1 million trillion a lot of trillions here, more configurations than chess. And so the early versions of AlphaGo and AI beat the top-ranked human Go player, 4 out of 5 matches. But now, AlphaGo versus AlphaGo Zero, AlphaGo Zero beat AlphaGo 100 times out of 100 matches. So this just goes to show you how good our AI is becoming, especially in the gaming world. Artificial intelligence is big in healthcare, artificial neural networks, robotic process automation, random forest classifiers, ensemble methods. It's there. It's been there for quite some time. And you can see that artificial neural network was used actually back in the 90s. So this is not, it's quite, and it's only just maturing more and more with every passing year. Artificial intelligence and mental health. This is an area, traditionally mental health is one of those industries that doesn't get as much funding, but lately has been getting more and more funding. So there's actually more money that's actually pouring into mental health, especially technology, the intersection of technology and mental health. There's quite a bit that's happening there. Okay, so the question always comes up, as we see that we have all of this technology that we've started to build around artificial intelligence, the question then becomes, are we cyborgs? And and I always say that it's kind of like it's too late. We are already cyborgs to a very, very large extent. We're in what I call the integrative period. So this is starting to introduce us to cybernetic systems theory. And this is where AI, machine learning, autonomous systems, and cybernetics kind of clashes together. and creates a great pairing. So we already today are we have wearables. We've got cochlear implants down in the lower left. We have artificial retinas that are being explored, which is the bottom middle. We have wearables up in the upper left-hand corner. The one in the upper right-hand corner, that's farther off. We're ways away from that. Kind of the retina, contact lenses, those kind of things. They're working on that stuff, right, for night vision and all kinds of other crazy, wild stuff. Augmented reality, mixed reality, and holographic projections on a small surface like that. So and this is just touching the surface, right? I mean, we're currently going through a technological integrative period where we're using more and more technology and keeping it more approximately or proximal in its distance to us. And one of the biggest ones is almost every person on the planet is holding a cell phone these days, and it's a smartphone, right? It's a smart computing device. It's beyond a phone now. So, and we are already cybernetic organisms. That's where my point is going here. So, we've gotten so good in terms of, we've got this idea. Remember what we talked about earlier about this idea of information, this data to knowledge, right? Well, it all comes back to this gap. And today, really, the gap is. It used to be I had to be near my computer. I didn't have a cell phone or a smart device that was close by to me. If you backed up 25, 30 years ago, if you wanted to get access to the internet, you had to go to your PC. You didn't have a capability to access it all the time. Now we have an ability to access it all the time through our phones. So this idea of are we cyborgs or not? It's too late. We're already there. I mean, so we have through our personal computing devices access to a ton of information that we didn't have. So if you think about it, it's this idea of being able to get this information. It makes us to a certain extent, it makes us superhuman, because in you backed up 20 years ago. You could say, hey, give me what's the current astronomical position of Pluto? And usually, if you backed up 100 years ago, you'd have to go talk to an astronomer. You'd have to go to the local university and say, hey, and then they would have to figure it out. Like, I think it's over there, right? And they'd have to pull out the books and figure out. And it depends on who you talk to. Nowadays, it's all, you just type it in. What is the current astronomical position of Pluto? And the internet will give you the information in less than a second. So it's literally something that it's the timing. There's more time spent in typing in the question than the answer coming back to your phone. So this is what's interesting about the idea of, again, back to, are we cyborgs? Well, we are, right? I mean, we are already that. The only difference is we haven't taken the phone and integrated it into our bodies yet. But even then, to a certain extent, we're already doing some of that to keep prolonging our lives, like pacemakers. It's a perfect example of a cybernetic relationship between technology and humans. We've got quite a bit more that we've been doing and continue to do. Okay, so we can do and ask all kinds of questions now that give us access to information so much more quickly than before. And again, back to, it has made us, if you compare what it is we are today to what we are and where we were even 30, 40 years ago, the internet and our ability to use the internet and this massive connectivity that we have has made us all very, very, very superhuman in a way. And so to a certain extent, we just continue to build that out and make it even stronger and make ourselves stronger in that respect. And we do have an imperative to try to get other people to a certain extent connected. That would be great. But there are always, unfortunately, That's one of those areas that not everyone is on equal footing right now. So that's things that we have to work through. Is how do we get more of the population integrated and to creating ability to be part of this this process we call the World Wide Web. Okay, so this is some things to think about, and then we're wrapped up here. So this is things to be thinking about as you go through the process of learning about machine learning and developing your skill sets. One of the things that AI and being in the artificial intelligence world is kind of having an R&D mentality. If you want to be successful in terms of working on artificial intelligence at the corporate environment, we have to develop use cases that have good return on investment, and we usually start with something small that we can grow over time. And one thing that we teach within our curriculum is this idea of the final mile, operationalization of a machine learning model, either in an autonomous system, whether that be a vehicle, a bodied system, or an unbodied system, whether it be a software system. Remember, autonomous systems aren't always bodied, right? They're not always a vehicle. They're not always a robot. Sometimes autonomous systems, they're unbodied systems within software. So, okay, so I think that's all I have. Something fun to think about. This was something that was built 2018. So these are top 10 quotes built by InspiroBot. This is actually a bot that would give you some interesting quotes. So one of the first ones is don't be a winner, just be yourself. So this is the top 10 quotes. So we'll start off with top 10 here. And then number 9, rule number 9, don't throw rocks at people when they're meditating. Probably a good rule. Number 8, if you had that on a t-shirt, you would be loved. Number 7, don't get upset about your cake, just drive. That's kind of an interesting one. Number 6, should we just get rid of extraterrestrials? Which is interesting because, I don't know, that's assuming that they're already here. Or maybe we are the extraterrestrials. Maybe InspiroBot knows something that we don't know. Number 5, the fact that you know that you are sad makes you smart. Interesting insight. How would the world look if everyone you know started hooking up with telemarketers? Kind of a weird saying. I don't know. Got to think on that one. Number 3, delude your loved ones and say something useful. That's kind of like a mean quote. Number 2, someone has to cry, why not you? Again, we're kind of going the wrong direction with these. This is kind of interesting, but these were the quotes that were generated by this AI, again, back in 2018. And last but not least, we all have the power to make multi-resistant virus spread across the globe, which is quite prophetic because that was a quote that I pulled from Inspiro back in 2018. With that, that's all. That's our intro to machine learning and autonomous systems, your first lecture. And usually these lectures don't run into the 40 minutes, but this is a prep one. Usually my lectures will be about 20 to 30 minutes, usually around in that time frame. So with that, I'm going to sign off on this, and I will see you in the next lecture.